Hey everybody, how's it going? Stoner Dave here, and I finally got a day off. Saturday, of course. But this video has been a long time in the works, right? See, a while back, I was on the old YouTube and I saw Detroit Wrecker's video where he's talking about how he fucked up his amplifier. He's claiming that he put his voltage regulator in backwards and that it fucked it up, that he was reading two different voltages is why he thought it was the regulator, and what have you, right? Neither here nor there. So, first thing I want to tell you, he didn't fuck it up by putting the regulator in backwards. That's not what he did wrong. He thinks that's what he did wrong, but that's because he doesn't know anything about electronics, but that's not what he did wrong. Now, what he did wrong did fuck up the regulator, no doubt. But something you should understand, He's using a 7806 voltage regulator, right? So we go up here, we check out 7806 voltage regulators data sheet, right? One moment here, I'm going to pull that up again. Three-terminal positive voltage regulator, LM7806. Input voltage maximum, 35 volts. Also an option with a maximum of 40 volts. So there's two different versions of this particular component. Let's see here, electrical characteristics, output voltage, minimum 5.76, maximum 6.24. Line regulation at 60 millivolts. Load regulation, 60 millivolts. Quiescent current, 8 milliamps. Quiescent charge current, 1 milliamp at VN 8.5 to 25. And current output of 5 milliamps to 1 amp gives it 0.5 milliamps. Input voltage, 8.5 to 25. Pretty cool. Output voltage drift, about negative 0.3 millivolts per degree centigrade. That just means the temperature can affect how much it's going out. Output noise voltage between 10 hertz and 100 kilohertz is 10 microvolts. Neat. Short circuit current limit, 2 amps. That means that if you have a short circuit on it, it'll go 2 amps. The nice thing about this particular voltage regulator is it actually has internal components in there to protect it against putting it in backwards. It has a reverse polarity protection built into it. So what that means is that if you put the chip in backwards, it's not going to damage anything. It's just not going to work, right? So, why am I calling to make fun of Detroit Wrecker? Well, I'm making fun because Detroit Wrecker sees this and he says, "Oh, that's a transistor." Right? Sees this. This is actually a transistor. But it doesn't necessarily mean it's a transistor just because it's in this particular package. Voltage regulators are not transistors. They're integrated circuits. Three-terminal positive voltage regulator. Now, the reason it's not a transistor is a certain kind of device, right? This is a transistor. This is a, what is this? It's a tip 42C. Tip 42C. Now, what do I know about the tip 42C off the top of my head? All I know is that it's a transistor. But a little bit of my tools that I have at my disposal here. Hook that up there. Hook that up there. Hook this up here. And I click test, and I get, what do I get? I get that this is a PNP silicon BJT. Yeah, that's what it says right here. Basically, I have all the information from the data sheet up on my screen here because the equipment that I have it hooked up to gives me all the specs on this thing. I mean, I can go way deep into this thing and find out all kinds of neat shit about it. I don't really need to do that. It's all right there. PNP BJT. Now, there are other kinds of transistors, what are called field effect transistors, or FETs, FETs, as you will. So, BJT, FET, these are types of transistors. Now, you say, how do you know they're transistors just because you get a FET and a BJT? Well, BJT stands for bipolar junction transistor. FET stands for field effect transistor. The T means transistor. Now you find a voltage regulator, which I don't know if I have one on hand right now, easily available. I think these are all transistors. Tip 31. Tip 31. My eyes aren't as good as they used to be, but I think that's tip 41. Up tip 31. Lots of tip 31s. Tip 31. Tip 31. I think these are all tip 31s. I think I got a tip 42 in here somewhere. What's this? Huh. This is one of the things I want to bring up here, but I'll get to that later. So, what makes a transistor? Well, really, it's the definition of what a transistor is. See, transistor can do really one of two things. It can act as an amplifier to amplify an input signal, or can act as a switch. Now, I happen to have a circuit right here that's showing transistors being used as a switch. See? There's two transistors acting as two different switches here. This one, when transistor comes on, this turns on. Transistor turns off, this turns off. Transistor turns on, this turns on. Transistor turns off, this turns off. Now, the capacitors are actually controlling the switches. The charging of the capacitor, once they reach a certain voltage, turns the transistor on. Transistor comes on, current's allowed to flow through it, and the LED comes on. When one transistor comes on, the voltage at the collector of the transistor goes to zero, and because this capacitor has about 8 volts of charge on it, and the other side of it drops down to basically zero, well, it goes to a negative voltage. Negative voltage turns the transistor off over here, and the LED turns off because there's no current flowing through it, and the capacitor begins to charge. Once it gets charged, transistor turns on, and the other side has a negative voltage on its base, turns the transistor off, and it just keeps going back and forth, which is why these LEDs are flashing the way that they are. They're basically, it's a timing circuit, right? But that's what transistors do. They act as switches, or they can be used as amplifiers to amplify a signal. Now, a voltage regulator doesn't act as a switch, and it can't amplify a signal. Voltage regulator just holds a voltage at a steady point so that the current beyond can use that steady voltage. You won't ever see a voltage regulator being used to switch or amplify a circuit. It's just there to provide a constant source of voltage. Now, let me think where I put my fucking regulators if I have some. Well, I don't really, but what exactly is going on with the circuit? Why did it fail? Right? Because he thinks that he put in the regulator backwards. Now, he had 6 volts on one plate and 10 volts on the other. The LM7806 has reverse polarity protection, which means that if you put it in backwards, it just won't work, right? It's as if it's unplugged. So how did he get 6 volts on one plate and 10 volts on the other? Well, without the schematic available to look at it directly, I can't tell you all the details, but I can tell you what I know. So he had the regulator in properly, and he said he's going to burn the circuit in. And he had an ohm meter there. Now, this is a more sophisticated ohm meter than the one that he has. His would be more like, where's my cheap row? My cheap ohm meter. I have a cheap one around here somewhere. This is my good one that I use like basically for everything. And this one doesn't have the setup like his does. Right? Because he's got a more common multimeter. His is actually one that you'd go get at Harbor Freight for like $5 or some shit like that. And I have one that I got off of some website for like $5 or $10. I think I got it on Amazon. I can't really remember, but because I'd gotten it so long ago. But where did I put that cheap piece of shit? Well, anyways, most common multimeters, they actually have 3 places to plug in here. One that is used for reading ohms, voltages, capacitors, diodes, or whatever, depending on limits. And then they have another one that will plug in just to read current. Now on mine, the dial, when you go to current, it puts it into current mode. You don't have to change the leads there. But typically, we don't really measure current, right? We don't usually measure current. We usually measure voltages, and we can calculate current using Ohm's law. But Detroit Wrecker had his meter, and he had it in the current mode to measure the current. And then he put it on his amplifier, trying to measure the voltage. Now, the reason this is a problem, right, is when you're measuring current, you put the meter in series with the circuit, right? Then the current flows through the meter, and the meter gives you a reading on what the current is. When you're measuring voltage, you put the meter in parallel with the circuit. The voltage goes through both the meter and through the circuit, and it can measure the voltage on there, no problem. Now, the reason why it can be damaging to take the configuration of the amp meter and put it in parallel with the circuit is the configuration for the amp meter is designed to have a really low impedance. Now, this low impedance is so that you don't affect the circuit that you're trying to measure. If you put a real high impedance in series with the circuit, the current's going to be really low, and you're never going to be able to measure it properly. Likewise, if you take a real low impedance and you put it in parallel with the circuit, you're going to bring the impedance way down, and you're not going to be able to get a good measure either. So what he did was he had his meter with the leads plugged into the wrong spot so that the meter had a real low impedance. Then he went to measure the voltage. putting it in parallel with the circuit. And then he left it over the weekend or however long he was gone while he apparently went out of town to go do whatever it was that he was doing. And he left it there. This is the reason why it melted the lead of his meter. See, if the issue wasn't the meter wouldn't have been affected, right? Because there wouldn't have been any current going through those leads. Get it? He had a lot of current going through those leads, so those leads got really hot and melted. Now, you just saw on the data sheet for the 7806, it can only handle about 2 amps of continuous usage. So, it got wrong. Now, why was he getting 10 amps on one and 6 amps on the, 10 volts on one and 6 volts on the other? This is pretty easy to explain as well, because if you're expecting 6 volts on both, then both sides should be connected to that 6 volts, right? Well, the thing is that there's going to be a level of impedance or resistance between the 6 volts and the component you're measuring voltage at. Doesn't matter what it is. There's going to be some level. When he put that meter in parallel with one of those resistances, he caused that to become a really low impedance on that side and the expected impedance on the other. So when he measures the voltage on the one side, he's getting 6 volts. On the other side, he's getting 10. The side with the 6 volts is the side that he actually fucked up by putting that low impedance on. See, the meter is trying to keep the 6 volts going. So it has to choose where it's going to have the 6 volts. 6 volts over here. 10 volts came because of how the impedance was. The low impedance got the low, or the high impedance got the high voltage, right? The low impedance has a real high current, which means a low voltage. High current means low voltage. The meter, seeing 6 volts there, didn't think anything about the 10 volts on the other side. It just did what it did. Because he had such a low impedance, though, he burned up that regulator. That's what he did. Now, he could try to say whatever he wants to say he did and make up whatever fucking stories he wants. The fact of the matter is that he fucking burned it up because he didn't know how to fucking use his meter right. He didn't know what the difference between a regulator and a transistor. And he's trying to fucking tell people about electronics that he doesn't know anything about. Now, I'm not familiar with the amplifier that he's looking with, and I don't really know too much about the tubes, right? I believe he said that there are 12AX7s. So I'm going to look up 12AX7 data sheet, see what I can find out here. All right, 12AX7. Typical characteristics. Okay. Okay. Capacitance. Okay. Operating characteristics. 250 volts. Jesus Christ. Let's see. I don't really know a lot about these things, so I'm looking at it here to figure out what I can find out. Let's see. Limiting values. Okay. Let's take a look at it in PDF format. Okay. Wow. 62.5K for the input impedance. Output impedance. Let's see. Okay. Everything's in kilos. God damn, that's fucking high. No wonder fucking nobody wants to use fucking tubes. Yeah, so you have to use a vacuum tube, or when you use vacuum tubes, you have to use a transformer for your output impedance because the output impedance is so fucking high. God, it's no wonder, right? Ohms. All right, so 50 volts is the max. Okay, that's what I was wondering, because I was thinking to myself, why is he limiting himself to the 6-volt regulator? Like, use something like this. This is a 5-terminal variable voltage regulator. Now this guy, you can see he's got 5 leads, but you can just make a few adjustments and go from that 6-volt regulator with 3 terminals and add the other 2 terminals and be just fine. And you can go now from 1.5 all the way up to 35 volts with this guy. What's that mean? Well, these tubes, they respond differently depending on what the plate voltage is, right? I'm assuming that's what he's looking at as the plate voltage. He's trying to heat it up. So if you're at a 6-volt plate voltage, you've got a certain amount of power or gain or whatever you're looking at for the plate voltage. Again, not too familiar with vacuum tubes. I don't fucking use them. I use fucking transistors fucking all the time, but I don't use fucking vacuum tubes a lot. But I get the idea, that their biasing is going to be based a lot on the plate voltage, given my experience with field effect transistors, right? So looking at it, and I'm saying, all right, well, we got this thing here that can go all the way up to, god damn, 180 volts, 300 volts. These are limiting values that I'm seeing on this thing. Here is UF. I don't know what that is, but 6.3, 12.6 volts. All right, so there we go right there. I'm guessing that's the one that he's working with because he's got the 6 volts that he's working, following around that area. This guy right here, you go below that 6 volts all the way up to double that 6 volts easily with this. And it's showing here that it can go up to 12.6 on there. I'm only guessing, right? I can't express that enough, that I don't know enough about these tubes to be able to tell you exactly what's going on with that 6 volts. But a variable regulator like this, where you can dial in whatever voltage you want just by changing the capacitance, not the resistance between 2 terminals, you can really get a lot more variety out of this thing. He's talking about how he wants to be able to have an amplifier that will do all these different sounds, but he's limited by the design of this, and he's limiting plate voltage, something that, from what I hear, is pretty important to the performance of an amplifier. So, not being an expert myself, I'm just throwing it out there that why not use something like this, It's also the LM317. Let me pull up that data sheet real quick. LM317. LM317. Yeah, here we have a variable regulator. Output options, adjustable output to a fixed output. And so you have a voltage in, you have a voltage out, you have a R1, R2, and there should be some capacitors in here as well. V out max 37 volts, V out min 1.25 volts, VN max 40 volts. There are a shit ton of different regulators and everything. And yeah, the 317, 3 terminals. Yeah, go figure, right? So yeah, it's a very reasonable substitute to use for his fucking amplifier there. Da 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 da. Surprised I don't have more regulators. What is this? This right here is not labeled, so I know they're all the same, but I don't know what they are. But they're 3 terminal, and that means I can test them with my little doohickey here. And I can see what they are. Do a little test. And it is a PNP Silicon BJT. Wonder what the model number is on this guy. Tip 42. I have a shit ton of tip 42s. Oh well. I was really hoping that I'd come across one of the 3 terminal regulators that I have, because I do actually have quite a few of them. But not today. Let's see. Let's go find please. LM386. So you know, calling the 7806 a transistor would be akin to saying that all of these are all op amps, right? Because while some of them might be, more of these are counters and logic gates and everything. These are actually just a bunch of chips that I didn't have packaging for. So I grabbed a ASD fucking foam and put them in there. Well, it's very unsafe to refer to a regulator as a transistor. You know? It's like, what's he gonna call this, right? What's he gonna call that? Transistor? No, this is an IR sensor. It has absolutely nothing to do with transistors. But he would call it that because he doesn't fucking know what a fucking transistor is. What's this? This might be a regulator. Let me check. So I do have some. I'm just finding one. NPN Darlington transistor. God damn it. It's nice to have this. Actually use one of those. And it's got a flyback diode on there as well. That's a Darlington. I better keep that here. What's this? Is this another Darlington? Might be. It could be fucking a regulator. I'm hoping it's a regulator. Well, This is a MOSFET. So it's MOSFET, MOSFET. Stands for metal oxide semiconductor field effect transistor. Each letter stands for something, right? But it's not a regulator. And this is really hard to explain the difference between these things without, oh, I didn't know I had that. So, just so you can see, this is it's a tilt switch. You can see inside there there's a little ball of mercury actually. And what happens is it turns, it connects or disconnects the probes in there. The mercury being conductive inside the vacuum. And you get yourself a cool little switch. Kind of like a reed switch, but affected by the tilt. Here's another one here. This one's leads are bent a little bit. Let's see if you can see that. Yeah, it's blurry, but you can see the thing inside there. It's kind of neat. Bought a whole bunch of sensors a while back. I thought this would be kind of neat to have them, but didn't realize I'd be seeing somebody like Detroit Record making a video about transistors, not knowing what the fuck a transistor is. Yeah, this is probably 3906. $39.04. I was close. All right, nothing in there. Maybe in this pile of sensors, I will have a voltage regulator. So this is a motion sensor. It works by detecting changes in the motion of things. And this is a water level sensor. So obviously to sense the level of water. Very interesting. I did not know I had this. Cool. All right, nothing in there. Those are all potentiometers, ICs. No. Dependent resistors. Yeah. Light dependent resistor. The resistance across there changes according to the level of the light, the intensity of the light, or the brightness, you might say. I can't believe I do not have a fucking regulator on hand. Maybe there's one over here. Well, I mean, I got that one, but looking for a 3-terminal, like the one that Wrecker broke by putting his meter in wrong. And like I said, he's going to probably say he didn't put the meter in wrong. He'll probably make up some bullshit excuse that I'm making shit up or something, but I'm telling you the exact fucking thing he did. It's the only thing that would explain him having 6 volts on one terminal and 10 volts on the other. It's all J-fits. Ah, here it is. Here's the meter I was talking about, the cheap one. So, yeah, you can see here. See, let me take the probes off of here. All right, so as you can see here, there's one common right here, right? One common right there. On this side, you can see it says, it's got a V, an ohm symbol, a hertz. It's got a little diode. It says MA and a little micro A. It's all right here. Then over here, it says just 10 amps, right? 10A. So he had this hooked up like this, and he measured voltage. On this side, this particular multimeter, which is a real cheap one, similar to the one that he has there, the Harbor Freight value meter, this has approximately 3 mega ohms of impedance in this configuration. However, plug it in here, and all of a sudden we have ourselves approximately 2 ohms of impedance between these terminals. So when he puts this in parallel with this circuit, a whole bunch of current goes flowing through these probes. A whole bunch of current goes flowing through these probes. The voltage that's on this side, right? The side that he's reading the 10 is going to be lower, right? I don't have a makeshift of the circuit that he was working with, but I can tell you right now that he put this thing on. He probably put it on like this, right? Look, it's showing some kind of a voltage, right? It doesn't have a fucking clue, but doing something, right? It's trying. It's sitting there trying to read those voltages, but it's not, but I turn it over to my amp reading. Now all of a sudden it can try, right? And it's not going to, right? But if I do this and I hook this up so that I'm kind of getting the current going through here like this, it's telling me it's getting me about 14 microamps, right? It'll read the current. And the circuit's working just fine, but I take it off, all of a sudden the circuit's not working right? Because it's got an open line. Now, I'm not going to put this in line with the voltage. No way. Even though this is a cheap-ass fucking meter, it is less than 10 fucking dollars. I already know I don't want to put this in parallel with the circuit because it's going to cause problems, right? Let's see, 10 amps. Maybe I can measure see what we got. Sorry, my dog's going nuts over there. Let's see if we can read this here. I was really close when I guessed that impedance. 1.5 ohms. 1.5 ohms. 2 volts across 1.5 ohms. I don't think it'll create much of a problem if I try to measure the voltage across this LED. It's just 2 volts. So we'll see what it does. Oh, it's still in current reading. Let's see. It's actually not doing anything. It's all the current's trying to go through the meter. It's not giving me anything across the LED. That's how low the impedance is. It's only 1.6 ohms. It's very dangerous to put your meter like that on a circuit. It'll fuck up your meter and fuck up your circuit. As is seen with the voltage meter, it fucking, or the voltage regulator, it fucking burned that thing up. So, do not, I'm going to repeat it, do not put your voltmeter in the current reading position and try to measure voltage. It's very bad for your circuit, very bad for your meter, very bad for everything. He left it. That's why it fucking melted the fucking lead off. I mean, who would do such a thing? Oh, yeah, Detroit Wrecker. What, buddy? What? What's the matter, huh? You throwing a fit over there? Nobody playing with you, huh? Yeah, this is my little buddy, Milo. Come on up here, buddy. Oh, yeah. Mm-hmm. My buddy Milo, he's a really good boy. Yes. Got him from the Oregon Dog Rescue about, 8 months ago, huh? Mm-hmm. And he's been a good friend. He's a good friend. Probably wants to go outside right now. So I'm going to thank you all for watching. And remember, transistors do not regulate voltage. That's a voltage regulator. Transistors can amplify or switch a signal. That's it. They either amplify or they're going to work as a switch. That's it. People that call voltage regulators transistors do not know anything about electronics. That's just a fact. Just a fact. They don't know anything about electronics. If they knew about electronics, they would know a regulator, not a transistor. Regulator. Transistor. Now, what's funny, 7806 looks exactly like this, right? It looks exactly like this. So, looking at it without looking it up, one may assume that the 7806 is a transistor. But that's the whole reason why we look at data sheets for our components before we start using our components. See, I grabbed this off the shelf and I see it's a tip 31C. Tip 31C. Tip 31C doesn't tell me very much, right? If I don't know what tip 31C is. Now, in this particular case, I know it's a PNP. I think it's PNP. I know it's a bipolar junction. And by the packaging, I can tell that's a high power one. That is, this thing's designed to have high currents running through it. See, this whole thing up here at the top, this guy right here, that is connected to the gate. No, bipolar junction. No, it's not the gate. It is the, let's see, collector base emitter. It's connected to the emitter. And it's like this. So you can hook a big heat sink onto it. You can hook whatever heat sink you want onto it, from just using this to a giant one. Now, this here is a PCB board that I designed quite a while back. It's naked, nothing on it. And there's actually a spot for two different regulators on there. Right here and right here. You can tell it's for a regulator because of the way it's got that big ass fucking pad there for this guy. Now you say, well, how do you know it's not for one of those guys? And I said, well, it could be, right? But everything's surface mount on this thing. There's very little through hole that's going on here. As far as through hole components, there's a couple connectors, one big capacitor, And really that's it, right? Everything else is surface mount. And transistors that are going on there don't need heat sinks. And I know that just because I designed it, right? But it's neither here nor there, right? It is what it is. I'm going to take this guy out now, though. And I'll get this posted so that I can continue on with my world. And, if you have questions, comments, or concerns, feel free to comment down below. And I will answer any questions you have. If you have an insult that you'd like to make, feel free to make your insult. And I will follow up with your insult, probably with another insult of my own. But believe me, if you really want to challenge me on this, you're going to find yourself in a world of hurt, because I've got a shit ton of books that will all agree with me when I say something. So it's up to you if you want to take that chance. But it is what it is, man. Detroit Record doesn't know what a transistor is. And he doesn't seem to know how to use his multimeter either, because he hooked that in wrong. He doesn't know the proper way to put in his fucking voltage regulator, because he clearly had it in right. And he's like, oh, it must have been wrong. But no, it was fine. It was just his stupidity on how to use his fucking meter. He didn't know how to use his fucking meter. Go figure, right? All right, buddy, let's go. Come on, let's go. Let's go. Let's go. All right. I'll talk to you all later. Peace out.